What if I told you that one of the most powerful artificial minds ever created, Microsoft's quantum AI, has peered into the digital abyss and returned with a prediction that could fundamentally alter our place in the cosmos? Forget blurry telescope images or faint radio signals for a moment. Imagine this: an AI running complex simulations based on everything we know suggests that conscious life, thinking, feeling, self-aware beings might have evolved on Proxima Centauri B, the exoplanet practically next door. This isn't science fiction, it's the bleeding edge of computational astrophysics. But what does it really mean? Are we on the cusp of confirming we're not alone, or is this just a ghost in the machine? Let's dive deep into this electrifying possibility. We're standing at the dawn of what many are calling the next golden era of space exploration. Rockets are launching with increasing frequency. Telescopes are probing deeper into the universe than ever before, and a new, powerful vision is taking hold. The idea that humanity's ultimate destiny lies not just on Earth, but out there, among the stars. It's a dream woven into our cultural fabric, from ancient myths to modern blockbusters. But finding concrete evidence of life, especially intelligent life, has remained stubbornly elusive. Enter a player no one expected just a few decades ago: artificial intelligence. Microsoft's quantum AI isn't your average chatbot or image generator. Think of it as a hyper-intelligent digital brain, capable of processing information and running simulations at speeds and complexities that dwarf traditional computing. It was tasked with a monumental challenge: simulate the conditions on Proxima Centauri B, or Proxima B for short, an Earth-sized planet orbiting the closest star to our Sun, Proxima Centauri. The AI didn't see anything, it didn't detect a signal. Instead, it built a virtual Proxima B, layer by digital layer, based on the astronomical data we've painstakingly gathered. It factored in the planet's likely mass, its orbit, the type of star it circles, the potential for an atmosphere, the brutal radiation levels, possible energy sources, temperature ranges, and crucially, the chance for liquid water. Then it ran the simulation, not just once, but likely countless times, exploring different variables and pathways. And out of this complex digital crucible emerged a staggering possibility. Under certain conditions, not just simple microbial life, but conscious, intelligent life could potentially evolve and thrive on this alien world just 4.2 light-years away. The implications send shivers down the spine. We're talking about our nearest stellar neighbor potentially hosting beings capable of thought, awareness, perhaps even emotion. It's the kind of revelation that shifts paradigms, rewrites textbooks, and forces us to confront profound questions about our own existence. And this is a crucial, but we need to anchor ourselves firmly in reality. This is a prediction generated by a simulation. It's a hypothesis, an educated guess made by an incredibly sophisticated machine, but it's not a discovery etched in stone. The AI didn't find little green men waving from a digital window. It found a pathway, a possibility based on the parameters it was given and the models it used to simulate evolution and planetary science. Think of it like a weather forecast predicting a chance of rain. The conditions are right, the models suggest it's possible, even likely, but you don't know for sure until you feel the drops on your skin. In this case, the raindrops are actual, verifiable evidence of life, which we absolutely do not have yet from Proxima B. So what do the people who spend their lives looking for alien life think? As you might expect, the reaction within the scientific community has been a fascinating mix of excitement and profound caution. Dr. John Smith, a fictional but representative leading astrobiologist, captures this sentiment perfectly. He acknowledges the sheer novelty and power of using AI simulations like this, calling the concept incredibly fascinating and groundbreaking. It opens up entirely new avenues for exploring possibilities on worlds we can't yet visit. However, Dr. Smith immediately tempers this excitement with a vital dose of scientific rigor. We must remember, he cautions, that simulations are not direct evidence. They are powerful tools for modeling hypothetical scenarios, for exploring the what-ifs. But until we have concrete data spectra from advanced telescopes showing biosignatures, maybe one-day signals, or even findings from future missions that could get closer, these predictions remain speculative. He stresses the need for healthy skepticism. It's easy to get swept away by the sheer coolness of the idea AI predicting conscious aliens. But science demands more. The AI might have crunched the numbers and found Proxima B's conditions permissive for life, even complex life, based on our current understanding. But permissive is a long way from proven. We don't have boots on the ground, probes in the atmosphere, or telescopes powerful enough to definitively sniff out life signs there yet. As Dr. Smith emphasizes, these AI predictions are invaluable guides, helping us refine our hypotheses and potentially pointing our instruments in the right direction. But they absolutely do not replace the hard graft of actual observation, data collection, and exploration. Despite this necessary caution, the very fact that an AI has reached a point where it can even make such a sophisticated prediction about conscious life is, in itself, remarkable. It's a testament to the exponential growth in our computational power and our ability to model incredibly complex systems. Think about it. We're using human-created intelligence to simulate the potential emergence of non-human intelligence on another world. It might not be evidence of life, but it's powerful evidence of how far our intelligence has come. It could be the first glimmer of a future where AI acts as our advanced scout, digitally exploring thousands of worlds and helping us prioritize the most promising candidates for our limited observational resources. Let's delve a bit deeper into the science that makes Proxima be such a tantalizing target, both for astronomers and for Microsoft's AI. Its prime location is within the habitable zone of its star, Proxima Centauri. You've likely heard this called the Goldilocks zone, an orbital region where the temperature is potentially just right, not too hot, not too cold, for liquid water to exist on the planet's surface. And liquid water, as far as we know, is the non-negotiable solvent for life as we understand it. Every living thing on Earth depends on it. Finding a planet in this zone is like finding a promising plot of land in the cosmic real estate market. But location isn't everything. The AI simulation didn't just check the address, it looked at the property details. A crucial factor is the planet's atmosphere. Does Proxima B have one? We don't know for sure, but it's plausible for an Earth-sized planet. An atmosphere acts like a planetary thermostat and shield. It can trap heat, keeping the surface warm enough for liquid water even if the star is relatively dim like Proxima Centauri, which is a red dwarf. Perhaps even more importantly, it can act as a protective blanket, shielding the surface from harmful stellar radiation and cosmic rays. This shielding aspect is particularly critical for Proxima B. Red dwarf stars like Proxima Centauri are notoriously temperamental. They are known for unleashing powerful stellar flares, sudden, intense bursts of radiation and charged particles. These flares could potentially strip away a planet's atmosphere over time and bathe its surface in sterilizing radiation. Life trying to emerge or evolve would face a constant barrage. However, a sufficiently thick atmosphere, perhaps coupled with a global magnetic field, which we also don't know if Proxima B possesses, could offer significant protection, creating pockets or even widespread areas where life could potentially gain a foothold and evolve, sheltered from the star's fury. The AI simulation likely explored scenarios where such an atmosphere exists and calculated the odds of life arising under that protection. Now here, where the prediction gets truly mind-bending, the suggestion of conscious life. Most searches for extraterrestrial life focus on biosignatures, chemical traces that indicate any kind of life, likely microbial. Think pond scum, not philosophers. The vast majority of life on Earth throughout its history has been non-conscious, simply reacting to its environment to survive and reproduce. Conscious life implies something far more complex: self-awareness, the ability to think abstractly, to experience subjective feelings, maybe even to ponder its own existence. The AI simulation, fascinatingly, didn't just stop at life possible. It crunched the numbers on the potential evolutionary pathways under Proxima B's simulated conditions and found scenarios where the complexity threshold for consciousness could, theoretically, be crossed. It didn't predict what this life would look like: humanoid, insectoid, something utterly bizarre. It just suggested that the emergence of mind in some form was a possibility worth considering. This immediately throws open a Pandora's box of questions. Could life on Proxima B be utterly alien, perhaps not even carbon-based like us? Could it use a different solvent than water? Could its biochemistry be built on silicon or something even more exotic? If so, how would consciousness manifest in such a being? Would its thought processes, its emotions, if any, its perception of reality be so radically different from ours that we wouldn't even recognize it as conscious, or perhaps even as alive? Imagine encountering beings whose fundamental reality is based on manipulating magnetic fields, or whose communication occurs via complex chemical exchanges we can't detect. This AI prediction forces us to confront the limits of our own imagination and biological chauvinism. We tend to look for reflections of ourselves, but the universe might be far stranger and more diverse than we assume. AI, unbound by biological constraints in its thinking, might be better equipped to simulate and predict these truly alien possibilities, pushing the boundaries of astrobiology into realms previously confined to philosophy and science fiction. To truly grasp why this AI prediction is making waves, let's quickly revisit Proxima B itself. Discovered in 2016, its detection was a major event. Finding an Earth-sized planet orbiting the very next star over was electrifying. Its size suggests it could be rocky like Earth, rather than a gas giant. And as we've discussed, it sits tantalizingly within the habitable zone. However, its proximity to its star is extreme. Proxima B orbits Proxima Centauri at a distance of only about 7.5 million kilometers, roughly 0.05 astronomical units. For comparison, Mercury, the closest planet to our Sun, orbits at about 58 million kilometers. This tight embrace means a year on Proxima B whips by in just 11.2 Earth days. This closeness also means the planet is likely tidally locked, with one side perpetually facing the star, experiencing eternal day, and the other facing away, eternal night. Life, if it exists, might be confined to the terminator zone, the twilight region between the scorching day side and the freezing night side. And then there's the radiation. Being so close to an active red dwarf means Proxima B is likely blasted with X-rays and stellar flares far more intense than anything Earth experiences. As mentioned, a substantial atmosphere and magnetic field would be crucial for survival. These challenges make Proxima B a complex and potentially harsh environment, but not necessarily a lifeless one. Life on Earth, after all, thrives in incredibly extreme conditions, from volcanic vents deep beneath the sea to arid deserts and icy wastes. For years, scientists have debated Proxima B's habitability, running their own climate models and speculating about its potential. Now, Microsoft's quantum AI adds a powerful new voice to this conversation. It's not just offering another theory, it's demonstrating a potentially revolutionary approach to exploring these questions. AI-driven simulation could become a primary tool for surveying the vast numbers of exoplanets we're discovering, digitally, visiting worlds years or decades before we can send physical probes. Self-promotion integrated naturally. If you're finding this journey into AI, space, and the search for alien consciousness as mind-blowing as I do me a favor and hit that like button. It really helps the channel reach more curious minds. And if you haven't already, please consider subscribing and ringing that notification bell. We explore the frontiers of science and technology every week, diving deep into topics just like this, and you won't want to miss what's coming next. So, where do we go from here? How might this single, speculative AI prediction actually shape the multi-billion-dollar enterprise of space exploration? If AI can simulate environments and predict the potential for conscious life, even theoretically, could it become our chief strategist in the search for ET? The prediction about Proxima B could be just the opening act. Imagine scaling this up. Future iterations of quantum AI, perhaps even more powerful machines yet to be built, could simulate the conditions on hundreds, maybe thousands, of exoplanets residing in the habitable zones of distant stars. Instead of relying solely on the fuzzy data points we get from telescopes, a wobble here, a dip in starlight there, AI could build detailed virtual models of these worlds. It could explore a vast parameter space, testing how different atmospheric compositions, geological activities, or orbital dynamics might influence the probability of life emerging. Think about the efficiency gain. Currently, choosing which distant star system to point our incredibly expensive telescopes at, like the James Webb Space Telescope, involves difficult trade-offs and educated guesses. AI could provide a ranked list of most likely to host life candidates, potentially even differentiating between likely microbial and potential for complexity consciousness. This wouldn't replace observation, but it would focus our precious resources far more effectively, maximizing our chances of making that historic discovery. With the advent of true quantum computing fused with AI, the possibilities explode. We're not just talking about simulating a single planet, but potentially entire solar systems, modeling the intricate gravitational dances and energy flows that shape planetary evolution over billions of years. Quantum AI could run simulations of abiogenesis, the origin of life from non-life, under wildly different chemical and physical conditions, potentially revealing pathways to life completely unlike Earth's. Could AI eventually help us identify planets harboring not just life, but intelligent, technologically capable civilizations? Could it simulate the evolution of societies, predict likely forms of communication, or even analyze potential alien signals hidden within cosmic noise? Could AI sift through vast datasets from SETI, search for extraterrestrial intelligence, projects with unparalleled pattern recognition abilities? What if an AI could model not just the planet, but the likely evolutionary pressures leading to intelligence, giving us a much clearer picture of where and how to look? The prospect is staggering. AI not just predicting life, but actively helping us find and perhaps even understand it. What if this simulation is the first step towards AI-assisted first contact? Of course, this immense power brings profound ethical considerations. If an AI, even with caveats, flags a planet as having a high probability of conscious life, how do we react? Does that prediction place a greater responsibility on us? Should we prioritize sending messages or probes to such locations, potentially interfering with an alien biosphere or civilization, even unintentionally? The Prime Directive from Star Trek suddenly feels less like fiction and more like a necessary policy debate. The discussions around SETI have already touched on this. Is it wise to actively broadcast our presence, METI messaging extraterrestrial intelligence, or should we just listen? AI predictions could intensify this debate. If an AI suggests a civilization might be hostile or perhaps fragile, how does that influence our decisions? How do we ensure AI predictions, which are based on algorithms and data potentially containing human biases, don't lead us down ethically questionable paths? we need to develop ethical frameworks for astrobiological AI, right alongside the technology itself, balancing our insatiable curiosity with cosmic prudence and respect for any life we might find. Furthermore, AI could fundamentally change how we search. Our current methods are heavily biased towards finding life as we know it, carbon-based, water-dependent on Earth-like planets. But AI, capable of processing data and recognizing patterns without human preconceptions, might identify entirely new categories of potentially habitable environments. Perhaps life thrives in the dense atmospheres of gas giants, or in subsurface oceans on icy moons far outside the traditional habitable zone, or on planets orbiting pulsars. AI could analyze atmospheric spectra for combinations of chemicals that don't fit our known biological models, but could indicate a completely different kind of life. It could force us to abandon our terrestrial assumptions and embrace the truly alien, looking for life, as we don't know it. This connects to another profound area: AI's role in understanding consciousness itself. The AI prediction for Proxima B isn't just about aliens. It touches upon one of the deepest mysteries of science and philosophy. What is consciousness? How does it arise from non-living matter? If AI models can simulate the conditions under which consciousness might emerge elsewhere, could studying these models teach us something fundamental about the nature of awareness, thought, and subjective experience here on Earth? As AI itself becomes more sophisticated, mimicking human cognitive functions, the line blurs. Could an AI eventually become conscious? Is the Proxima B prediction a subtle foreshadowing of AI not just predicting consciousness, but participating in it, or helping us finally define it? This takes us into deep philosophical waters, but AI's involvement in these questions seems increasingly inevitable. And let's not forget the engine driving these future possibilities: quantum AI. Its integration into space exploration is poised to be revolutionary. Classical computers struggle with the sheer complexity of simulating quantum mechanics, which governs matter at the smallest scales, or modeling the chaotic interactions within vast astrophysical systems. Quantum computers, harnessing the bizarre principles of superposition and entanglement, can tackle these problems exponentially faster. Imagine simulating the formation of galaxies, the precise chemical reactions needed for abiogenesis, or even designing warp drives or wormhole generators based on new physics uncovered by quantum simulations. Quantum AI could unlock breakthroughs in interstellar travel, planetary terraforming, or asteroid mining that seem like pure fantasy today. It might not just help us find habitable worlds, but give us the means to reach them and potentially even shape them. While Proxima B is the current star, pun intended, of this AI prediction story, it's crucial to remember it's just one planet among billions. Astronomers are actively studying many other exciting candidates in habitable zones, like the planets in the TRAPPIST-1 system, 7 Earth-sized worlds orbiting a nearby red dwarf. Kepler 452b, sometimes called Earth's cousin, or LHS 1140b, a super-Earth, in a habitable zone that might retain a thick atmosphere. What makes Proxima B special right now is its sheer proximity, and the fact that it was the subject of this specific, high-profile AI simulation regarding conscious life. Comparing Proxima B's harsh but potential environment with these other candidates highlights the diversity of potentially habitable worlds. AI simulations will be invaluable in comparing these apples and oranges, helping us understand which factors are most critical for life and guiding the search across the galactic neighborhood and beyond. Should we focus on the nearby but potentially irradiated Proxima B, or the more distant but perhaps more stable environments elsewhere? AI might provide the data-driven answers. So what can we take away from this incredible story of AI predicting conscious aliens? For me, it's a powerful reminder of the interplay between human curiosity, technological advancement, and the humbling vastness of the universe. We built these incredible thinking machines, pushed them to their limits, and they reflected back at us a possibility that resonates with our deepest hopes and questions. Are we alone? The lesson here isn't just about space. It's about how we approach the unknown, how we handle powerful new tools, and how we balance excitement with critical thinking. The AI's prediction is thrilling, a spark for the imagination. But the real progress comes from the rigorous scientific process that must follow the painstaking observation, the data analysis, the skepticism, the willingness to be wrong. In our daily lives, too, we're constantly bombarded with exciting claims, new technologies, and potential breakthroughs. This story reminds us to embrace the wonder, to ask the big question, but also to keep our feet grounded, to seek evidence, and to understand the difference between a compelling simulation and proven reality. It teaches us the importance of long-term vision. The search for life, like many great endeavors, requires patience, persistence, and collaboration across generations. This prediction from Microsoft's quantum AI is undeniably provocative. Does the possibility of conscious life on Proxima B fill you with hope and excitement? Or does the speculative nature of the AI simulation make you lean towards skepticism? Could AI truly be the key to unlocking the secrets of extraterrestrial life? Or are we putting too much faith in our digital creations? I'd love to hear your perspective down in the comments below. What kind of life, if any, do you imagine might exist on Proxima B? Thank you for joining me on this exploration of one of the most fascinating intersections of AI and space science. I sincerely hope you found it thought-provoking. Wishing you all good health, clear skies, and endless curiosity. And finally, if you enjoyed this deep dive and want to stay updated on the latest breakthroughs in space, AI, and future technologies that are shaping our world, please hit that subscribe button and join our community. We've got so much more to explore together.